Comets are ancient, dating back to the origins of our solar system, over 4.6 billion years ago. Some comets have orbits that take them well beyond Pluto, into the mysterious Oort cloud. A comet's tail always points away from the Sun due to the solar wind pushing on the emitted gas. Comets are time capsules, containing pristine material from the early solar system, untouched by heat and radiation. Comet impacts may have delivered organic compounds to Earth, crucial for the development of life. The largest comet nucleus observed is Hale-Bopp, with a diameter of about 60 kilometers. Comet tails can stretch for hundreds of millions of kilometers. Comet Hyakutaki's tail extended nearly 570 million kilometers. Comet Hale-Bopp will not return for another 2,500 years, making its 1997 appearance a once-in-a-lifetime event. Comets can break apart due to gravitational forces or thermal stress as they approach the Sun, sometimes explosively. Most comets are not visible from Earth without a telescope, except during their close approaches to the Sun. Comets can have multiple tails, consisting of dust and ionized gases, each reacting differently to the Sun's influence. Water on Earth may have come from comets, as suggested by the similar hydrogen isotopes in both. Comet Shoemaker-Levy 9 famously collided with Jupiter in 1994, providing a direct observation of an extraterrestrial collision. Comets can sing, emitting low-frequency oscillations detected by spacecraft, caused by interactions with the solar wind. Every time a comet orbits the Sun, it loses material, slowly diminishing in size and mass over millennia. Comet dust has been collected and returned to Earth, providing direct samples of extraterrestrial material for analysis. Comet orbits can be altered by close encounters with planets, which can dramatically change their path through the solar system. In history, comets were seen as omens, often interpreted as harbingers of doom or significant change in ancient civilizations. Comets are composed mostly of water ice, dust, and frozen gases like carbon dioxide and methane. The Rosetta mission successfully landed a probe on the comet 6-7P/Churyumov-Gerasimenko, a first in space exploration. Some comets are sun grazers, passing so close to the Sun that they can disintegrate from the intense heat and tidal forces. The Great Comet of 1843 had a tail so long it could cover the distance from Earth to the Sun. Comets differ from asteroids in that they have an atmosphere, coma, and a tail when they get closer to the Sun, while asteroids do not. Comet orbits are usually highly elliptical, taking them on long journeys to the outer solar system and back. The color of a comet's tail can vary from white to blue, depending on the size of the dust particles and the gases it emits. Comet 6-7P's orbit takes it around the Sun every 6.45 years, a relatively short period for a comet. Comets emit X-rays when solar wind particles strike the gases in the comet's coma, a phenomenon discovered in the 1990s. Cometary impacts have created numerous craters on Earth, the Moon, and other celestial bodies throughout the solar system. A comet's nucleus is so porous that it has been described as a dirty snowball or icy sponge, with a density much lower than that of water. Cometary activity increases as it nears the Sun, causing the ice to sublimate and jets of gas and dust to burst forth. The brightest comet of the 20th century, Comet Ikeya-Seki, was part of the Kreutz sun grazer family. Comets have been visited by several spacecraft, including Giotto, Stardust, and Rosetta, enhancing our understanding of their composition. A comet's journey around the Sun can be affected by the solar wind and radiation pressure, altering its trajectory and activity levels. Not all comets return to the inner solar system. Some are ejected into interstellar space by gravitational interactions. The nucleus of a comet contains clathrates, ice that traps gases such as carbon monoxide and methane, which can erupt as it warms. Comets often have unstable orbits due to perturbations from the gas giants and other external forces, making long-term predictions difficult. Comet McNaught in 2007 became so bright that it was visible to the naked eye even during the day. Cometary orbits can be predicted, but they become increasingly difficult to calculate accurately over time due to gravitational perturbations. Some comets may originate outside our solar system, potentially carrying information about distant star systems and their chemistry. Comets can have outbursts, sudden increases in brightness and activity that can dramatically change their appearance. The smallest comets can be less than 100 meters in diameter, making them difficult to detect until they are very close to the Sun. Comets contribute to the interplanetary dust cloud, shedding material that spreads across their orbits. Historical records of comets date back over 2,000 years, providing a rich historical perspective on their appearances and impacts on cultures. Scientists use comets to test theories about the solar system's formation and the origins of water and organic molecules on Earth. Comet tails are formed when the comet heats up near the Sun, causing ice to turn directly into gas and release dust. Some comets have highly inclined orbits, allowing them to cross the paths of planets and potentially leading to dramatic interactions. Cometary orbits are chaotic due to interactions with the planets and the Sun, leading to unpredictable paths over centuries. Comets are remnants of the early solar system, largely unchanged since their formation billions of years ago. Comets can create meteor showers when Earth passes through their debris trails, illuminating our night sky with spectacular displays. Comet nuclei can fragment into multiple pieces during close approaches to the Sun, resulting in several smaller comets following similar paths.